Hey guys, this is Michael Choi from Yorba Linda High School, period 5, and I'm going to be doing iCT lesson 21. Um, so let's start off with this. We're going to have a conversion tester and a conversion, and for the sake of convenience, we're going to um, have it as static values instead of creating an entire new object that converts with private values stored into the objects. In other words, we're going to be able to say something like system.out.print line version.convert to decimal. Something like that. We're basically going to be able to do that. Okay, so I wanted to cover a couple of things with you right before I started. So what numbering systems are is basically what each number in the when written, what it represents. Okay, so if I wrote something like 1001, that does not represent 1001 in binary, because what it represents is 1 to the 2 to the third, 0 times 2 to the second, 0 times 2 to the first, and 1 times 2 to the 0th, okay? One thing I would like you to note is, notice how 1 and 1 are the same, 0 and 0 are the same, 0, 0 same, 1, 1 same. The 2's right here are all the same, and notice how the order is represented to how many, what place it is, okay? So this is the thousandths digit, 3, hundredths, 2, tenths, 1, ones, ones place is 0th order, okay? So what happens here is when we have 1001, it's basically calculating this, which turns into 8001. We add all of these together and we get 9. So what this in binary represents is 9 in decimal, okay? 645 is just some arbitrary number I decided to pick. What it represents in, so we're going to basically be doing decimal to decimal conversion, which is technically going to be the same number. 645 is 645 in decimal, because they're both decimal. But I thought I might as well cover this because it might help lock in the concept of numbering systems. So it's going to be 6 100s, right? 4 10s and 5 1s, okay? So the way we're going to represent that is 6 times 10 to the second, 4 times 10 to the first, and 5 times 10 to the 0th, okay? This represents 1. The reason we're doing this is because in decimal, our base is 10, okay? So let's get started. What we're going to have is integers, and notice how these aren't strings, because I'm just going to be covering up to base 10. Past base 10, you're going to have to be using strings instead of and returning strings, because past base 10, you're going to have to be using 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, and so on and so forth. But I'm not going to be covering that, because if you understand this lesson, you should be able to do that by yourself. Anyways, we're going to have a value called finished number, and what our finished number is going to be is our number after it's modified to our next base, okay? So for convert to decimal, we're assuming we receive a non-decimal number, and we're gonna assume that this base represents what base this number is. And what we're gonna do is convert this non-decimal number into a decimal number, and that is represented by finished number. Okay, so notice how we have finished number, and notice we have to have one more value, integer order. And let's assume integer order is equal to 0. And what order represents is the order here, 3, 2, 1, 0. The way we're going to do this is we're going to calculate what this value is, this, and this, okay? And then we're going to add them all up to find what our decimal value is, okay? So this is converting binary to decimal. And the way we're going to do that is through a while loop, and we're going to say while number is not equal to 0, and I'll explain that in a second. Actually, let's let's try to figure out, here, I'll print something out and then I'll explain it right after. Okay, so what we're gonna do here is it's gonna print out. Okay, so if we give it a number like this, it's gonna print out 1 0 0. Okay, actually, let's make this a little different. Let's say 1 1 0 1. It's gonna print out 1 0 1 1. Okay, let's see if it works. 1 0 1 1. And then it prints out that last 0 because we initialize a finished number as 0 and then we return it and then print it out. So this that last 0 doesn't matter at all. But the reason this is important is because notice how this pattern of 1 0 1 1, or let's make it a little bit more obvious with something like 1 1 1, and then like let's put a 0 like right in here. So it should say 1 it should say 1 0 1 1 1 1 0 0 1. And notice how it's printing everything backwards, and this is going to be very useful to us. 1 0 1 1 1 1 1 1 0 0 1, and that last 0 from the finished number. Okay, the reason this is important is because if we can pluck off each last digit, we can analyze this as this number, and then the next time it goes to the while loop, we can assume that it goes to this number, and then this number last. The reason why we say while number is not equal to 0 is because every time the way this works is it says, okay, we have a number like, let's say 159. Okay, we're gonna print out the number mod 10. That's gonna print out this number. So let's delete this. It's gonna print out a 9. Okay, after that, what it's gonna do is divide 159 divided by 10, and that's equal to 5.9. But since this is Java, that turns into 15. Okay. In our next loop, we have 15. Okay, 15 mod 10 is equal to 5. Okay, 5. And then, so it prints out the second digit, right? When it goes through the second loop, it goes through the second, it prints out the second digit. 15 divided by 10 is equal to 1.5. But this is Java, so it turns into 1 because of integer division. Okay. Next, we're going to say 1 mod 10, this is our third loop, is equal to 1, right? And 1 divided by 10 is equal to 0. Okay? Notice how when we get to our final number, the lowest number, or the largest units value, it turns into 0 because there's nothing else to hack off. So basically we're saying when there's nothing else to hack off, just stop doing the while loop because we went through the entire number. Okay? So right now we figured out how to find out what each of these first values are, and now we have to multiply them by the modifiers. 2 to the 0th, 2 to the first, 2 to the second, 2 to the third. And this is where our order plays in. Okay? Notice our order, every time notice how we're going from backwards. Okay? This, okay? So notice how our order is going from 0, 1, 2, 3. So we're going to have to, in the while loop, say order plus plus, because our order increases every time. And notice that each of these numbers are represented by multiplying it by the base to the order, okay? So it's going to be this. And then remember, we figured out that this entire thing is equal to the digits, the single units digits. And then we have to multiply it by base to the order. Okay? The way we're going to represent that in Java is math.pow base to the order. And every time we go to the next digit, our order increases by 1. We go to the next one, so on and so forth. So now what this should print out is, if we have something like 1001 from this example right here, it should print out 1008, because that's what we calculated right now. That's what it's printing out. And then a 0 at the end because of that final. See? 1008, okay? Now the next thing is simple. Notice once we have these numbers, all we do is add them up and we get the decimal number. Okay? The way we're gonna say that is finish number. So this is each individual number. Finish number is you just add it to the each individual number and then you get your decimal number. And this should be equal to 9. Yes, we got the correct answer. Let's assume we have 1 1 or 1 1. That's 1 times 2 to the 0th, which is 1, plus 1 times 2 to the first, which is 2. So 2 plus 1 is equal to 3. 3. Let's assume we get one more. 3 plus 1 times 2 to the second, which is 4. So this is 7. Okay, let's assume this is 0. So that's 1 times 2 to the 0th, which is 1, times 0 to the 2 to the first, which is 0, plus 1 times 2 to the second, which is 4. So this is 4 plus 0 plus 1, which is 5. Okay, and so now we know it's working. Okay, let's go on to our next method, from. Now, this is actually going to be much easier than you think, okay? Let's just, I'll explain to you in a second. Let's just copy and paste this right here, okay? When we say convert from decimal, we're assuming we receive a number that is a decimal number, okay? So this number is a decimal number, the numbers we use every day. Like 10 is equal to 10, 11 is equal to 11. 11 here would be represented as 2 plus 1, which is 3. So this is not a decimal number, but this is. And we're converting it to a specific base, okay? The way we're gonna change this into the specific base we want is just a few modifications to this. So notice how every time our numbering system is based off of tens, right? But we're trying to convert it to the numbering system of base. So like whatever this is, 2, 3, 4, 5, right? So we're gonna convert all of our tens into bases because we're doing the reverse process, right? But that means our bases must be something else. So we're basically switching around the base and the 10 for the 10 and the base. And that's pretty much it. So let's see if this works. So if I have a number like 63 and I want to convert that to base 1, 63 base 1, without doing the calculations because I don't want to bore you guys, should be 1111, something like that. Oops, wait. 1, 2, 4, 8, 16, 32. So it should be this. So 6 ones should be represented for this, if I did this correctly. And we already tested this one out. This is like 3. Oh, I mean, 1 plus 4, which is 5. Yep, so we got our correct answers. And let's do one more foolproof test just to make sure we got the right ideology here. Okay, so let's say we're gonna print out a number 724 in binary, okay? 724 in binary is equal to this. Assuming that's right, if we convert our binary to decimal, we're saying, okay, send this number. We have the base to 2 and convert it to decimal. We should receive 724. And look, we do. So it's simple as that. Thanks for listening. And if you guys get this, then you should be able to get everything else. But if you have questions, message me on Facebook or leave a comment. Thanks for listening and see you guys later.